Let's synthesize this and check. Read Verilog partial case assign dot v. So synth hyphen top partial case assign. See, we are seeing only one latch, correct? Because there is no latching behavior for y. For x alone there is latch. So there is only one latch inferred. Let us do our ABC hyphen liberty. Show. Let's look at it. So clearly, if you see y is not having any latch in its path. If you see in the path of y, there are no latches. This is what we expected, correct? In the path of y, there is no latch. In the path of x, there is a latch. In the path of x, there is a latch. So what is the enable condition of the latch? Look at this. There is a NAND gate. The B pin of the NAND gate is driven by cell of 0 and A pin of the NAND gate is driven by an inverter which is driven by cell of 1. So this is cell of 1 bar. So what we are seeing here, let us write it here. So we are having cell 1 bar dot cell 0 the whole bar. This is an AND gate, correct? So if I simplify this by De Morgan's theorem, what will I get? Cell 1 bar bar plus cell 0 bar, which is nothing but cell 1 plus cell 0 bar. This is my enable, correct? This is what is driving the enable pin. And this is exactly what we anticipated also, correct? If you see, the enable equation we anticipated was the same. Cell 1 plus cell 0 bar. Cell 1 plus cell 0 bar. This is the enable condition we anticipated here. Correct? Cell 1 plus cell 0 bar. This is the enable condition we anticipated and this is what we are getting here. So exactly our assumption was matching. Now, the D pin of the latch is driven by this condition. Okay, there's an AND gate and there's a combo cloud. So as an exercise, I leave it to you to check whether we are indeed getting, simplify the Boolean expression here and check for y and x we are getting the remaining inputs to be as expected by this. Okay, here and here I leave this to you as exercise. Kindly check the Boolean expression here and match it with the RTL expectation. Okay, so this is an inverter, this is a OR and invert gate, this is an inverter, again this is a NAND 3, this is NAND 2, and also you have the Verilog models for all these cells. So in case you are getting confused with what is this Verilog, what is the Boolean function implemented by this Verilog code, you can go back to our Verilog model in the Verilog files and check what is the exact functionality inferred here and try to work out the Boolean function here and check the Boolean function is mapping. Okay. So in this lab we saw, so far we have seen about incomplete case, complete case, and in case we are in all the legs of the case we are missing assignments, though we write default, still there can be inferred latches. That is what we have seen so far. Now one more important thing we saw about case, right? The case is not, it's not going to stop there. So if the condition is met, in case of if the condition is met, all the else part will be ignored and directly it will come to the exit of the if. Whereas in case of a case, even though the condition matches, the whole case will be evaluated. So if there are overlapping condition in case, there will be a problem. because the case is not mutually exclusive. When you write if, all the if, else if, else if, else if, else, all these are mutually exclusive. Only one will execute. Whereas in case it's not like that. So to illustrate that, we have an example here. That file is called bad case. So now if you see here, I have made this as 2 tick B 1 question mark here. So if you see here, upon 0 0 y is assigned to I0, upon 0 1 y is assigned to I1, upon 1 0 y is assigned to I2, upon 1 question mark y is assigned to I3. That means when select becomes 1 1, this will get executed. When select becomes 1 0 also, this will get executed, because the second bit, this bit can be anything. It can be 0 or 1. We are looking for this bit being 1. Now if you see, the condition called 1 0 matches this also, this also. So now here, this is going to confuse your simulator. This will cause synthesis simulation mismatches. And here, when in overlapping case, you are at the mercy of simulator. Different simulator behaves in a different way here. You will be at the mercy of simulator also here, because this is not expected to be happening. The tool can, and even the synthesizer can simplify it to choose the most optimum way. So see, now this is the latest matching option. So the synthesizer will try to choose this. The simulator will get confused. Let's see what is going to happen. You will see the synthesis and simulation getting confused with each other. So I_Verilog bad case tb_bad case dot v /a dot out, and we are going to do gtk wave tb bad case dot vcd. So we have I0, I1, I2, I3, select, and Y. Boom, you go here. See now, when it's becoming 1 1, it is latching to a value called 1. It is neither following I2, it is neither following I3. It is getting confused and it is latching onto a value called 1. It is neither, because something is happening, it's getting confused. Because condition 1 0 is also matching, condition 1 1 is also matching. See here. Clear? Now, this is clearly not expected, correct? The tool is clearly getting confused here. Now let us synthesize this and try to simulate the netlist.